G'day you rates, hope you're going well. Today what we're going to do is look at the next exercise, which is, again using and looking at algebra, and we're just making moves on expressions. So today we're going to look at how to simplify problems where what we're doing is multiplying and dividing powers. So over the next two lessons we'll be learning some index laws, and today what we're going to do is cover the first two index laws. Right, so to go through the index laws, what I'm going to get you to do is write down your heading, which is index law 1. Okay, and then what I'm going to do is get you to write down, I'm going to explain how the index law works, and then you're going to put down, in conclusion, the index law. Okay. All right, so if we imagine this problem here, we've got a to the 2 times a to the 5. Well, what we can do is imagine this written in what we call expanded form. That's just a times a, that's this one here, multiplied by another 5 lots of a. So 1, 2, 3, 4, 5. I think that was right. So a times 1, 2, 3, 4, 5. Yes. So that would be a to the a times a times a times a. So we know that that's going to be once, twice, 3, 4, 5, 6, 7. That's going to be a to the 7. And if you look at the original problem, you might notice that there's a shortcut to doing this, that you don't have to write it out in expanded form. Because what you do is when you get what I call common bases, that is, common bases here of a number being multiplied, all you do is you add the powers together. So it's going to be 2 plus 5 is 7. Okay. So what I want you to do is write down that in your book. So make sure you've got the explanation. And then can you please write down the conclusion that if we've got an index a to the m multiplied by an index a to the n, and these have what we call common bases, then all you're going to do is add the powers together. So I've got there n plus m or m plus n. It doesn't matter which way you do the addition because it has that property. All right, so you're going to write that down, and then you're going to, so pause the video here to copy it down and then unpause it when you're ready. All right, so now that you've got that down, what we're going to use is that index law to help us simplify the following expressions. Okay, so again, write down that and write down the instruction that it wants us to do something in particular. Okay, so what we're going to do is with a, we're going to note that we've got common bases there. So we've got a base 5 and a base 5. And because it hasn't got an index, we're going to put one in. If there is no index listed in at the top of the number, it's just 5 to the power of 1. Okay, so you could write any number 8. Just say, if you ask me what my favorite number is and I said 8, I could say 8 to the 1. Okay, because 8 to the power of 1 is just 8. All right, so we're going to write it like that. So what we do is we write down the base, okay, which is 5. And then all we do is we simply do 3 plus 1. So this is 3 plus 1. We add the powers together. So that's 5 to the 4. Now we could evaluate that one if we wanted, because we do know what 5 to the 4 is. But let's just leave our answer like that just for the moment. That would be fine. Okay, this next one here is going to be x to the 5 times x to the 7. What we're noticing is that we've got a common base, so x and x. So we're going to use that rule. So now that we've identified that, we write down our base, which is going to be x, and then we simply add the powers together. So we go 5 plus 7 is 12. So that's going to be x to the 12. All right, the third example looks, excuse me, a little bit nasty, but let's just take it a little bit at a time. Okay, so this one has got some bases being multiplied, or some indices being multiplied, but also got these numbers out the front. So what we can do is we can just treat them like we would if you're asked the question, what is 2 times negative 5? So we've got a positive number times a negative number. That's going to be negative. 2 times 5 is equal to 10. Okay, then what we've got is we can see that we've got an x here and an x here. So we've got common bases. So we write down the base And we just add those powers together. So we've got 4 and 2, which gives us 6. Then we've got this also a common base, a y and a y. So we're going to write down the base, and we've got y to the 3 times y to the 6. So that is just going to be y to the 9. And there's our answer. All right. So that really is index law 1, okay, that when we've got these bases being multiplied together, that we've got the same base, all we do is we add the powers together. It's really important to note that if I've got, say, something like x to the 5 times y to the 3, the rule doesn't apply because that base is different to that base. So we don't actually run the rule on that. And that's why we're not going to simplify this x to the 6, y to the 9 by saying something like xy to the 15. Okay, so this would just simplify to be x to the 5, y to the 3. That would be the end of the story with that one. Okay, so the second index rule is, or has to do with division. So again, what I'm going to get you to do is to write down the index law 2, then pop this down, a to the 5 over a to the 2 equals, and our conclusion. All right, so what we'll do is work this through, and then you'll pause it at the end of me doing this so that you can copy this into your books. All right, so the way this one's going to work is we note that a to the 5 over a to the 2 is just a times a times a times a times a, so a by itself 5 times, over a to the 2, which is a times a. Now that could be rewritten as a times a over a times a times a times a times a over 1. All right, so notice that all I've done is I've split these up. So I've still got 5 a's being multiplied together in the numerators and 2 a's being multiplied together in the denominators. Now, why did I do that? Well, we can see here that those two are going to cancel out because a times a over a times a is just going to be 1. So that's going to cancel out, leaving us with a times a over 1, or a to the 3. Now you might note there that there's a really easy way to do that, that if you notice that you've got common bases, here we've got a base A and a base A being divided, then all you do is you subtract the indices. We just do 5 take away 2, which is 3. And that's what the rule says. So a to the m over a to the n is equal to a to the m take away n. That's a really quick way of simplifying. Okay, so ensure that you've got that into your books. So you've got the explanation of the rule, all right, so you know exactly how or why the rule works. And then you've got your conclusion here as well, the actual rule itself being defined. All right, so pause the video here and make sure that you've got that copied down. Now that you've got that copied down, what we're going to do is the examples, of which I think I've got 3 of them. So can you please write the word examples, and then please write down the instructions. Simplify the following expressions. All right, so again, with this one here, what we're going to notice is that we've got the same base and the same base. So that means that this rule, index law 2, applies. All right, so we've got 10 to the 5 over 10 to the 3. So that's going to be 10 to the, and all I do is I remove 3 from 5. That's going to be 2. We could evaluate that quickly as well. That's going to be 100. All right, the next example is this one here. Okay, so we've got negative 10 over 2, x to the 6, x to the 4. Okay, well, the 10 over 2 can be simplified. So what I do with that is I go, well, okay, what is the highest common factor of 10 and 2? Now, 2 goes into itself once, 2 goes into 10 5 times. So the highest common factor was 2. Now this x to the 4 and x to the 6, they're going to be divided. So the rule applies that when I've got common bases, x and x being divided, I simply need to subtract the powers. So this is going to be negative, first of all. We've got 5 in the numerator. Then we've got x to the 6, and we're dividing that by x to the 4. So that's going to be x, and 6 take away 4 is 2. So the answer to this question here is negative 5x to the 2. You could put over 1, but it's not required. Okay. All right, so the last example is this one here. And what I notice is that I've got a b to the 3 over a b, and a to the 10 over a to the 2, and c, well, that's over, or got no c up here. So the c is going to stay at the bottom. So I know that this a to the 10 over a to the 2, we've got the same bases, so all I'm going to do is subtract the powers. So I'm going to go 10, take away 2 is 8. So that simplifies to a to the 8. I've got b to the 3 and this b to the 1 here. So I'll write down the base and then subtract the indices. So 3 take away 1 is 2. Now, this c here has got nothing to do with anything at the top, so we just leave it at the bottom. So our answer there is a to the 8, b to the 2 over c. So can you please ensure that you've got all of those examples written in your books? And when you have, then I'd like you to do a bit of practice on this. So the exercise is 5J, and can you please do those questions? Good luck.